Low-pressure casting. The low-pressure casting process involves the upward pressure injection of liquid alloy into the mold cavity from below to form castings. Because the casting process is under controlled pressure, and the resulting product will be more dense and uniform, with no air holes and have better mechanical properties. It also results in great surface quality that requires no secondary machining. For example, low-pressure casting is the preferred method of making aluminum wheel hubs. Wheel hubs made in this method have 30% more tensile strength and better roundness. Gravity casting. Gravity casting is a process where molten metal is poured into a mold by gravity. It is generally used in non-ferrous castings such as aluminum and brass. Even though its product quality is not as good as low-pressure casting, it is still better than die casting if you require good mechanical strength. Parts made by gravity casting usually have reduced pores and enhanced part strength. Comparison of low-pressure casting and gravity casting. Low-pressure casting. Pressure. Use compressed dry air. Gravity casting. Pressure. Open air. Use gravity low-pressure casting. Mold and equipment cost. Relatively high. Fair. Production consistency. High, mostly machine operation. Involves manual labor and can be affected by atmospheric temperature and moisture. Suitable shape. Suitable for thinner wall and complex shape, but not for or very large part because air pressure cannot lift. Suitable for simpler parts. Typical product. Aluminum wheel hub. Special machinery. Robot arm. Suitable batch size. High. Low. Unit cost. Higher. Fair. Permanent mold casting. Gravity casting and low-pressure casting are also called permanent mold casting. Both processes use steel mold. It is permanent comparing to wood mold made in sand casting process. Steel mold is more expensive than wood mold but offers smoother surface quality of resulting part. Needs minimal grinding and cleaning. Sand casting. Sand casting, also known as sand mold casting, is a traditional casting process that uses sand primarily bound with clay or other adhesives as the molding material to produce castings. Sand casting has the following characteristics. Sand casting is the most widely applied casting method. The cost of molding materials is low, making it suitable for production of all scales. It can cast parts of various sizes and complexities. The making of molds and sand cores is relatively simple, requiring no complex equipment. Permanent mold casting. Mold. Wood and sand. Sand casting. Mold. Hot work steel. Mold cost. Low. High. Suitable metal. Non-ferrous. All. For example, gray iron. Surface quality. Smooth. Rough. Subtypes. Low pressure casting and gravity casting. Green sand. Resin sand. Shell mold. Dimension accuracy. Higher. Lower. Efficiency. Higher. No need to make sand mold for every piece. Lower. Die casting is a method where liquid or semi-solid metal, or metal with reinforcing elements, is filled into the mold cavity under high pressure and solidified under pressure to form castings. Die casting is suitable for the rapid production of small, precision parts. It possesses the following advantage. 1. Quality, precise dimensions and smooth surfaces. 2. Strength, 25 to 30% stronger than sand casting, with reduced elongation. 3. Consistency, suitable for thin-walled and intricate parts. 4. Efficiency, fast production and long die life support automation. 5. Economy, minimal machining needed, saving material and labor costs. Die casting. Pressure point 4500 MPa. Low pressure casting. Pressure point 2060 kPa. Mold cost. High. Lower. Unit cost. Low, because of high speed. Automated production. Higher. Mechanical strength. Lower, because of high production speed, some air are trapped in the part, and there may be oxidation slag in the part, typically cannot be heat treated. High, very pure molten metal liquid, suitable part dimension, smaller, complex shape with thin walls. Larger, suitable batch size, high, due to high mold investment. Lower, dimension precision, higher. Lower, allow insert molding, yes. No, material, most aluminum and zinc, non-ferrous. The main differences between aluminum castings and forgings lie in their manufacturing processes and the performance characteristics of the final products. Casting involves pouring molten aluminum into a mold, where it cools and solidifies into shape. This process is suitable for mass production of complex shapes. Forging, on the other hand, involves shaping aluminum material in its solid state by applying pressure through hammering, typically used for producing parts that require higher strength and toughness. Specifically, here are some key differences between aluminum castings and forgings. Mechanical properties. Forgings generally have higher strength and toughness compared to castings. The continuous grain flow during the forging process helps to enhance the overall performance of the product. Production cost. Casting is more economical for mass production of complex shapes, while forging is better suited for producing small batches of simple shapes. Surface finish. Cast parts may require more post-processing to achieve the desired surface finish, whereas forged parts, due to their production process, usually have a smoother surface. Production efficiency. Casting is suitable for quickly producing large quantities of identical parts, while forging is more cost-effective in medium to long batch production. The choice between casting and forging depends on the application requirements, expected performance, and cost considerations of the final product.